Hi, my name is Peter Wahinya from the Animal Genetics and Breeding Unit. As part of our videos on helping you better understand your analysis, I would like to talk to you about the importance of accounting for fixed effects. We can often observe phenotypic differences in a group of animals, and these differences arise from a combination of different genetic and non-genetic effects. As a producer or breeder, one of the primary concerns is selecting suitable animals to serve as parents for the next generation. To make this decision, phenotypic data on the traits of interest is recorded. In addition to the phenotype, it is crucial to gather data on non-genetic effects or environmental effects that influence performance. Non-environmental effects that influence performance are referred to as fixed effects. These effects include whether an animal was born and raised single or twin, its gender, season of birth, management group it belongs to, incidences of disease and parasite infestation, the mothering ability of the dams, and so on. These effects are essential to ensure a fair comparison between animals. Here is a simple example. If we were to compare two rams, A and B, that cut 3 kilograms of fleece as shearing, but one ram was born and raised as a single, and the other ram as a twin. Based on historical data, we know animals born and raised as single typically yield more wool on average compared to those born and raised as twins. To ensure a fair comparison, we should evaluate the performance of both animals relative to the average performance within their respective groups or types. For instance, assuming that the average fleece weight for singles in a flock is 2.8 kilograms and the average for twins is 2.2 kilograms, Ram A only exceeded the singles average by 200 grams, while Ram B exceeded the twins average by 800 grams in fleece weight. In this scenario, if they share the same management, Ram B demonstrates superior genetic merit compared to Ram A. In a similar way, we can adjust measurements for other fixed effects. This approach makes selection on breeding values more sensible than selecting on phenotype because breeding values take into account multiple environmental effects that could bias selection across different environments. As a result of this adjustment, the best-looking animals might not translate to better breeding values. To summarize, we have seen that accounting for systematic or fixed effects is crucial because it allows us to compare animals fairly.